dominate the market for launching communication satellites. We have created systems for our national security and our military power that are recognized as being critical to the U.S. Posture in the world. And so I think we are poised in the last couple of years of this century to be in a leading, if not dominant, position in what happens in the world with respect to space in the years to come. Not a bad heritage. But the times they are a-changing. Most of this is a cliche for you, but worth saying that with the end of the Cold War and the space race, the notion that you could measure the value of the civilian space program by whether it was ahead or behind the Soviet Union obviously has gone away. We're not behind anybody in any significant way. We don't need to look with big systems at the Eurasian landmass to understand preparations or lack of preparations for conflict on the Central Front in Europe, nor do we have to count Soviet ICBMs. So the requirements for our strategic intelligence systems are very different. The kind of military engagements that we're going to likely be involved in and are involved in around the world are rather different. And that puts different requirements on 21st century space capabilities. We have learned that for the kind of war fighting that we are likely to engage in, we being the United States through most of this, that space systems are increasingly important and that the ones we have are not very well matched to the requirements. So there's a kind of secular change underway in military space policy. As that graph a couple of times ago suggested, communicating via satellites is an integral part of the explosion of information systems in the world. Until 1971, again, only a few of us in this room can remember that far back, but some of us can. It was formally not legal to use communication satellites to communicate inside the United States. They were only international systems. It was a deregulation of the US market that started the growth that has exploded in the 80s and 90s of national and regional communication satellite systems, and has led to things like Intelsat and Inmarsat, global quasi-governmental organizations becoming obsolete. They essentially are no longer needed to manage global communication systems and are being broken up. A variety of communication applications from GEO, plus the rapid expansion of mobile communications. And maybe there is a business in high resolution 1 to 10 meter imagery on a commercial basis. We'll see. So what's going on? This is my segue into the future. And I'm going to talk about each of these separately. The big growth sector is commercial space, 20% growth a year by some measure of revenue. And most of that growth is in telecommunications. The National Reconnaissance Office is no weaker than it used to be. It's now acknowledged. It's rethinking what its role should be in the world of the 21st century. And it's changing away from almost total dependence on very large, very expensive systems to small, distributed, kind of very capable satellites. Any of you see a recent broadcast on CBS Evening News where the cameras were allowed in the clean room in the Lockheed Martin plant in Denver and the Hughes plant in El Segundo, where key elements of these systems were shown for the first time, not with much explanation. But the notion you could put on the evening news these large systems. Aviation Week says the biggest system was a La Crosse radar satellite. Since I don't have access to that kind of information, I can report what Aviation Week says and not verify whether it's correct or not. Sheila Widnall, back here now on the faculty, was Secretary of the Air Force when the Air Force created this vision of a transition over the next decade or two from an Air Force to an Air and Space Force, and after that to a Space and Air Force. So that the role of space in that segment of military operations is under transition. I'll spend a fair amount of time, since this is a NASA Space Grant talk, talking about NASA, with the word reinvention becoming a cliche. And things are merging. The jargon word for what has characterized the past 40 years is stovepipes. Everything inside its own compartment with very little cross-compartment fertilization. And I think that's changing, some cross-sector cooperation increasing, maybe not as much as it would be nice to see. All right, let's talk a bit about commercial. By some measures, but unfortunately not the ones, somebody in Lockheed Martin, these are Lockheed Martin slides if you have logo recognition. Somebody in their public relations office has to change this phrase. What is commercial space commerce? That's not very euphonious. But you see the growth, 86, $3.2 billion a year, 91, 11.5, 96, 26.7, and a projected 57.5. So that in 14 or 15 years, that's from $3 billion to $57 billion a year of activity not related to government space programs. And you see most of that is the services routed through satellites, not the building of the hardware. What is it? Here it's about 50-50 services and hardware, satellites, launches. And you see it's the non-glamorous ground equipment, which is a large portion of this market, rapidly growing kind of market, to the point where, by some measures, the revenues associated with the commercial sector are larger than the money that governments are putting into space. What is driving this is primarily the growth in various types of communication satellites. There's an analytic group in the Washington area called the Teal Group. And each year they put out a projection of how many satellites will be launched in the next 5 years. And you see their growth in 5-year projections over the past 6 years, from 650 to over 2,000 satellites. Fundamentally, only the most visionary of people anticipated 5 years ago the rapid growth in low Earth orbit mobile communications. Nobody thought about teledesics, or 5 years ago, I guess Iridium was just getting funded, just getting started. But this growth in communication by satellites for multiple purposes is something that's kind of snuck up on people. If you were in it to start, you have the potential, not the certainty, of making a lot of money. Today, it's mainly geostationary satellites for voice, television, and direct TV, and some data. But tomorrow's coming real fast. We were talking at lunch that Iridium, which is the first of the mobile communication satellites, mainly for lawyers. It's $3 a minute, I think, is what their billing rate is, and a fairly large. It's people who have to be connected wherever they are in the world so that they can do business. They're supposed to turn their system on in September of this year. This is a Motorola venture. Global Star, which is Loral, is close behind that. Ellipso and ICO is a system spun off from Inmarsat. And at least most of you can read this. And in the years to come, It is this wideband, high data rate, Ka-band systems, which essentially are going to put internet in space, that are the real growth area. So it's a different form of satellite communication. The optimists in the market look at numbers like this, again, and say, still less than a third of the people in the world have access to telephones at all. I mean, this blue is the percent of people in the world without access to any kind of telecommunication system, and say, we're going to make money filling that. And if they're right, the future may look something like this. This is a French colleague of mine named Alain Dupas developed this chart a few years ago. Here's Apollo with a peak in '65 of the money spent on science exploration and human space flight, kind of leveled out. Here's a later wave of space development as military systems became useful, but again, kind of stabilized and leveled out. And here's his projection of the growth of information-based space systems. And if anything like that happens, that is what's going to drive the future in space, not going to Mars or anything else. There is a derivative commercial space market, which is launch. This very controversial area of what is the launch market. This is one figure that some colleagues at Boeing worked out that says that over the next 10 years, 60% of the satellite market doesn't have a launch vehicle assigned to it yet, which, again, if you were in the launch vehicle business, you say, aha, market opportunity. And there are lots of organizations trying to capitalize on that market opportunity. Same people project something like this, that in the past decade, the US, because of taking the shuttle out of the commercial market and the slow startup of Atlas and Delta as commercial launchers, seeded a launch market primarily to Ariane, but also to Proton and Long March systems, that it's going to be a much more internationally competitive market in the next decade. This is, I guess, large communication satellites, primarily to GEO, rather than the smaller launches. How many of those are American systems, and do we care? I mean, sure, Delta is, and Atlas is, but Atlas is co-marketed by Lockheed Martin through the International Launch Systems subsidiary with Proton. So a lot of the profits from Proton launches go to Lockheed Martin. Sea Launch is a joint venture of Boeing, a Ukrainian rocket manufacturer, and a Norwegian drilling platform manufacturer. So that the US, one way or another, is in about 70% or so. It's only Long March, Ariane, and H-2A. H-2A is a paper rocket. The Japanese are trying to take their existing launch vehicle and cut its costs in half, which the engineers in this crowd should know is a pretty good trick, to take an existing design and reduce its cost by 50%. Are there other areas for future commercial growth? I'll come back to some of this, but some of these over the next 20 or 25 years will probably become sectors of high economic potential. I'm told that the major application of what's now called GPS, global positioning satellites, is probably going to be the timing, precise timing for things like computer systems around the world, rather than the navigation applications. And sometimes, somewhere down the line, projection, the US Air Force is going to get out of the business of providing that for free, and somebody else is going to provide it for a cost sometime. Remote sensing, a lot of talk about commercializing low Earth orbit. If Dr. Young is right, and 10 years after space station is up there, we'll forget how much it cost and concentrate on how much it's done. We will have industrial parks and private space platforms and lots of industrial activity in low Earth orbit. NASA released a report along with a private association last week on the potential of space tourism. And I'll come back to a couple of the others of these. I'm not in any way expert in the role of space-based intelligence systems, so this is kind of derivative, but I wanted to make some comments on it as part of this overview. There is a stated goal for the United States of our security depending on our information dominance or superiority. Our security planning for the future assumes that we will have better information than any potential adversary. Now, young people in here probably don't want to even think about a world in which there are nasty people out there wanting to do us harm. Those of us that are old enough to have lived through periods where there were nasty people out there wanting to do us harm, to say that it would be nice if we lived in a world where we didn't have to do any of this. But that's not the world we currently live in. NRO continues to push the technological frontier and continues to develop very advanced systems to carry out its missions. We're at the point of taking the imagery that formerly was only available to the president and people with very high clearances, and that was one of the problems in the Gulf War, and developing ways of putting that imagery into a fighter cockpit on a real-time basis. So a guy going out to fly a sortie has some sense of the best information available. This over here is not exactly NRO, but it suggests for the Bosnia conflict how we're using our space systems. National Security Agency, NPIC, this is old, it's now the NEMA, National Imagery and Mapping Agency, which takes the images from NRO satellites, Defense Intelligence Agency, CIA, et cetera, putting their information into various stateside-based systems which are communicated via commercial satellite into the Bosnian theater, plus some real-time work, and again, you can't quite see, but that's an Intelsat satellite with a secure internet channel on it. Real-time data feeds going through a system in England, but out to the commander in the front line in Bosnia. And again, that's the kind of hookup between the national security and military sectors I think more and more is going to happen. Again, it's not done with any publicity, but the imagery that NRO satellites collect is made available for environmental, for disaster warning, disaster relief, and humanitarian applications. So there's this cross-sector work of using the capabilities that are available. And again, here's another nice typo. Hopefully they're not multiple proliferations. And I hope that's not prediction. And the advanced technology coming out of NRO and I should say other military and strategic defense initiative programs are flowing particularly into commercial use, and some of the advanced technology coming out of the commercial sector is flowing into military use. I should have something in here that talks about the military. So I must have lost a slide along the way. Imagine there's one there. Here's the kind of stuff that the straight line military is talking about these days, is recognizing that space systems operate and are important on the full spectrum of activities related to U.S. security. At one end, economic power. and the other strategic nuclear conflict with, I like this, it's kind of new acronym to me, OOTW, Operations Other Than War. Humanitarian, natural disaster assistance, terrorism, peacekeeping, unconventional warfare, minor conventional, major conventional, theater nuclear, strategic nuclear. Space superiority supports the full spectrum of operations. It's a way of thinking about the role of space in military thinking and military strategy that I think has not been very common in the past. One of the emerging alliances there is the alliance between the Department of Defense and the commercial space industry, where DoD is recognizing that the investments that the commercial space industry are making give all kinds of capabilities the military can use without having to pay for all of it. And again, you see these are various Air Force and what's this, Space and Missile Command slides. The capabilities from commercial space systems, and this was mainly telecom, that the military could take advantage of. So a lot of that fertilization going on. The buzzword in military space right now is space control. At what point and how does the U.S. military ensure that the U.S. has total access to space for whatever purposes it wants to use space for, and denies that similar capability to our adversary? That's stated in military terms. We can't do that now, or we don't do it now anyway. At some point, we according to the military planners, want to know what's going on everywhere all the time in space. We want the ability to protect our own assets, prevent any damage to them, and negate the ability of others to use space. NMD's National Missile Defense, using space systems for missile defense, which is SDI, Redux, and integrated command and control over all of this. The systems to do this are not in place. The military doctrine to do it is not in place. The political will to do it is not in place. But if some aspects of the military leadership and national security community have their way, they will be in place. And space, the relationship between the military and what goes on in space will be rather different than it has been. All right, so I've taken 45 minutes and haven't said anything about NASA. That's good. It's good in a couple of different ways. I made a flip comment at lunch today that NASA's a sideshow, and that's too strong. But the reality is that the commercial, national security, and military space sectors, certainly taken together, overwhelm in finance, in level of activity, probably in technological innovation, what happened through NASA. What NASA does is get headlines and create images and visions, and those are very important things for the future. Today is an interesting day. It's the beginning of the 7th year of Dan Goldin's tenure as NASA administrator. He showed up April the 1st, 1992. None of us that met Mr. Goldin in his early weeks on the job would have predicted he would still be there 7 years later, but there he is. He is trying, almost by force of will, to change an institution with an immense amount of inertia. NASA learned a particular pattern of success from the Apollo program, and maybe a different pattern, but equally high inertia in its relationship with the scientific community in how to do space science. And changing that pattern has been very, very difficult. I think Goldin's changes are irreversible, but I'm not positive to that. A lot of people, general people in polls, when they're asked about NASA's budget, think it's about the same as the Department of Defense or Health and Human Services or something like that. It's useful once in a while to show a chart like this. This is the relative size of the NASA budget compared to other federal agencies. And most people, I think, don't have this image in their mind because of the visibility of what NASA does, that it is the smallest budget of the major agencies of government. And it is smaller than it was supposed to be. When Golden got there in '92, the NASA budget that was under debate in Congress at that time anticipated by now, fiscal '99, that the budget request would be $21 billion. Instead, it's $13.5 billion. So there's been a downsizing. If you combine correcting for inflation plus actual revenue loss of probably 35% of NASA's expected future. You see, the actual budget hasn't come down very much. In fiscal '95, it was 14 or 15, I guess $15 billion, and now it's around the 13 billion. But there's been this falling off of future expectations. The budget, I think, has stabilized. This is the '99 budget request out here, and you see it's flat for the next 5 years. Last year, there was some budget politics being played where NASA would threaten with this $2 billion cut over the next couple of years, but that was never real and has now gone away. And the budget is flat. So I think at least the financial future of the agency looks stable, but that's not growth, that's stable. These are NASA propaganda slides. Probably most of you have seen them. The revolution in cost of spacecraft from 590 to hoped for $74 million a spacecraft, the development time going down from 8 years to 3 years, the flight rate going up from 2 science spacecraft a year to 14 a year. Something like that is actually happening. The change from the big, if you did this for Cassini, it would be even a higher number than this, but a $2 billion life cycle cost for Galileo is what, a third more than the life cycle cost of 9 planetary missions. There has clearly been a shift in paradigm. The science program now has a theme, Origins, which has gotten, I think, both scientifically and publicly, a lot of positive reaction. The notion of looking for Earth-like planets in our celestial neighborhood and studying the birth and evolution of galaxies, stars, and planets as the organizing theme for the future. This program, OMB, is fully funded. Gave NASA in its budget this year more than it thought it was going to get in the Origins budget. I noticed when I got through putting through these view graphs, I managed to do this without any image of Mars. Just interesting. There is this new scientific theme of astrobiology, studying the origins, evolution, diffusion, and future of life in the universe, including the discoveries on Earth of all the places that life appears. There are these fascinating images of the surface of Europa that suggest some sort of liquid ocean under a frozen surface as a place to go look for life. Caught Time's attention. Now, a couple of years ago, you can tell how old this was. Dole drops, Clinton rises. No comments. This was the first discovery of extrasolar planets, a discovery which I think is disputed, by the way, this one. But front of time, somebody judges that's of great interest. Gene Covert was complaining about Hubble's discovery of the week, but here's a Hubble picture. Gene, of a galaxy field. And clearly the image of our place in the universe as an organizing theme for space science has provided a theme that had been missing for a long time. The Earth Science program, I think, is on the way to being improved. I'm not an expert. What used to be called Mission to Planet Earth and has recently been changed to Earth Science. If you wanted to play linguistics, understanding the reason for that change would be an interesting thing to do, but I don't have much to say about it. There's an attempt to privatize repetitive operations like the shuttle, and an ongoing debate right now of whether you might even bring the shuttle back into use as a commercial launch vehicle. There's a big couple $billion contract competition for SFOC, Space Flight Operations Contract. It's to run mission control and communications and that sort of thing. Not a very clear strategy about future technology and future launch systems. I think the country recognizes that launch is really an important area. We don't have our act together on launch, and I have a couple things to say about that in a moment. The central issue, maybe as always, is the future of humans in space. Of the $13.5 billion NASA budget, $7 billion goes to, in one form or another, to human spaceflight. And why is a continuing question. Current focus is us. I've got to proof this stuff. Is the International Space Station, and there's just the beginnings of the serious debate of what's going to follow the space station. Let's talk a couple minutes about station. There it is in all its glory. First element launch is supposed to be this summer. Even money whether it will actually be that or not. First two items are ready. The functional cargo block, which is back in the middle here, built by Russia, paid for by the United States, and the first connection node built and paid for by the United States. Might be a little clearer in this line drawing, which isn't quite as nice. But the service module, which is the Russian component, is behind schedule, and there's a decision next month of whether to wait for it, slip the initial launches, or substitute a US thing called the interim control module. Basic point is the program is still in trouble. It's still not under managerial control or budget control, but it will happen. It's too late for us to say, no, we're not going to do station. Why are we doing it? I'm not going to read all of these reasons why. Leadership during the 90s. Blah, blah, blah. The only point is the date of this slide is September of 1983. And the rationale hasn't changed very much, which is either good or bad. My own view is that there is an underpinning belief, almost an article of faith on the part of people that have thought about it in the United States, that humans in space have value. And we've got to test that belief. Shuttle's a camping trip. Shuttle, goes up, bad food, toilets don't work, et cetera. You can do some stuff for some period of time, but it's not the kind of it was never designed to be a laboratory to start out with. It was designed to be a transportation system to a space station. Finally, we're going to have the station. I think we can afford the test and see whether there's things of value. I'm kind of a cautious optimist that the answer will be yes. And besides, we have to do the station before we do anything else. Talking about going back to the moon or Mars is just, I think, idle talk until the station experience is under our belt. What are the issues for the future? One is, and maybe a A, or the critical one, is solving the transportation cost problem. This came out of an Air Force study a couple of years ago of the cost in millions of dollars per launch. This is the cost per pound to orbit, somewhere between $4,000 for the Long March to $16,000 a pound for the Titan. Shuttles down around $10,000 a pound. Ariane 5, they hope somewhere in this range. That's still a lot of money. You have to have very valuable applications with a very high probability of success to pay this much for access to orbit. We're, at this point, the only country in the world that's investing any significant money in advanced space transportation, and we're not investing nearly enough to solve the question of how best to lower the cost. So we'll see. Where do we go with people? What happens if station fails? Something I don't want to even think about. But it'll certainly have a chilling effect on humans in space for a significant amount of time. Do we put people, a lot of people in low Earth orbit? Here's an image that came out of the NASA Space Transportation Study. Let's see if I can, there's no up in space except that you want to be able to read it. So this is a zero-G space hotel with private transportation systems and probably some artificial gravity on some part of it and zero gravity on other parts. The recently released study says there is a big market for private space travel. What do you folks think? You're the ones that would be paying for it. Is there anybody here that thinks humans will never leave Earth orbit and go beyond it? Yeah. I wouldn't think so here. So the question only becomes when and who does it, right? So I can put up nice images. These are, I think, synthesis group images of a pretty large-sized lunar base and field geology on Mars. And those are the visions that a lot of people still carry. I'm not sure the young people of the world carry them as much as we that are descendants of the Apollo generation. But here's a view graph you haven't seen yet. And so remember, it's only a view graph. Anybody want to hazard a guess of what that is? Well, yeah, except it's the North Pole of the moon. And here's a mirror catching sunlight, reflecting it down so you can extract some water. And you can then build things around the edge. So this is, say, NASA's latest, or Pat Rawlings' latest conceptual vision of a outpost to take advantage of the discovery of frozen water somewhere on the moon, maybe. There's a chart here I like to use. You know, seems to me that the answer of whether people leave this planet for long periods of time depends on these two questions. Can you use non-terrestrial materials to support people? And can you do something of economic value? Only if the answer to that is both of those are yes, do you get full space settlement. If the answer is no, then you might get Antarctic-type bases where everything has to be exported and you do some science. If you can't make, if you can't use local resources, you might also have some tourists, a la Antarctica. And if you No, I'm sorry, I read that wrong. If you can't use local resources, then you probably have to have robot mines to do anything of economic value. If you can live off the land, but no economic value, then you'll get tourism and research. On the assumption research has no economic value, you notice. One other fancy view graph coming out of the same people at NASA on advanced studies. This is this year's concept of a solar power satellite, power tower. And there's enough interest to put some money in the current NASA budget to do some very limited technology validation and to check the economics. Both interesting things to do. You know, if this were valid, the idea of producing large-scale grid-level energy from space, that could be the billion-dollar application. One of the questions I have is whether things like communication satellites have anything any more to do with space policy. Or are they telecom systems that happen to be in space? That's what I mean by the word normalizing. Integrating space systems into larger human endeavors, communications, managing the Earth, environmental policy, war fighting, et cetera. Normalizing space, I think, is going to be one of the major trends of the 21st century for all of the areas except NASA. How much growth potential there are in areas like this remains, I think, to be seen. Do we know what we're doing? It's kind of the bottom line question. Does the United States have any kind of national strategy for space? This is kind of bootlegged out of a briefing by the current head of the European Space Agency, making an argument that Europe has to have a space strategy. And his perception, Antonio Rodota, is that the United States has a clear policy of space leadership. I've been inside the Beltway in Washington for 31 years. I wouldn't know where to go to find that. But again, I think if you start thinking about it, and maybe go back to if I can find it, one of these very early view graphs, this one. As the United States faces the 21st century in space, it is making an immense comparative investment in space capability compared to any other nation of the world. They're underpinning that is some sense, I think, of national will and priority that says, for the United States in this next century, space is one of the areas that we're going to be in and be in a leadership position. NASA is going to be important to that in doing science, in doing exploration, and providing some of the technology that will underpin the rest of these activities. But space in the 21st century is much, much broader than just what we have been used to seeing for the past 40 years. It should be an exciting time. Thank you.
Thank you, John. And before opening the floor to questions, I'd like to present you with a certificate of appreciation from the Massachusetts Space Grant Consortium.
Thank you.
We're very grateful for that inspiring lecture. I would also like just to call to the attention of the audience 3 of the future lectures in the Wednesday afternoon lecture series in Modern Space Science and Engineering, which is held at 3 o'clock each Wednesday in 37-212, that are closely related to areas that John brought up. On the 15th of April, 2 weeks from today, the subject will be Corona, those early spy satellites that John referred to.
Can we sell books?
That you know, if you will send some up here, we'll go and take orders. The lecturer, whom you know, is Dow Smith.
Yeah.
Dow Smith was at Boston University one of the founders of ITEC, is a neighbor of mine in New Hampshire. He said he's been aching for decades to be able to talk about this stuff. So that's on Wednesday the 15th. The following Wednesday, the 22nd, Professor Sheila Widnall of MIT, back from her duties as Secretary of the Air Force, will be talking about Air Force leadership in space, again picking up some of John's views. And then the following Wednesday after that, the 29th, Professor Eric Chason from Tufts University will be talking about new sciences that's coming out of the Hubble Space Telescope. So among the other lectures in that series, those three are particularly relevant to some of the areas that Dr. Logsdon has told us about. Now, I presume that you are willing to take some questions?
I'm here. My plane's 9 a.m. tomorrow morning. So, Harry?
I noticed on the pie chart that you had most recently on this, my right, that of the world space expenditure, the second most dominant country is France.
Yep.
Whose budget is fully 5 times that of the UK, 5 times that of Italy, significantly greater than Germany or Japan separately. Given that France is not a particularly strong supporter of ESA, where's all that money going? Does that mean that France has a robust military space program?
Well, I think I'd first of all would attack your premise that France is not a supporter of ESA. Many people in Europe think that ESA is an instrument for getting other countries to pay for French priorities. But the current minister overseeing the space program in France, Claude Allègre, is a committed scientist who doesn't think that human spaceflight is worth very little. It doesn't think he's worth much, and is not enamored with ESA's performance. There's a Gaullist view that space is connected to national standing and national grandeur that is pretty pervasive in France and has historically been a reason for the French space program to be so large. Plus, France has recognized that if Europe is serious about becoming an entity called Europe, it has to have a security posture as well as an economic posture, and space systems are important to that security posture. So France has taken the lead in trying to create a European security space capability, so far with 2 observation satellites called Helios, but with plans for the future. So there's some military, but it's mainly for France a political and scientific belief in the importance of space.
John, what's the fraction of a subsidy that the French government gives to Ariane?
Well, the question was, what's the subsidy for the French government to their launch system, Ariane? Well, if you could measure that, you'd have a lot of people in the United States happy, because then we could attack through the World Trade Organization the French subsidy. You know, one person's subsidy is another person's assistance, anyway. What's the subsidy that the U.S. government is providing to Lockheed Martin and Boeing to build heavy lift commercial systems to compete with the Ariane 5 in what used to be known as the Evolved Expendable Launch Vehicle program, but is now Delta IV and whatever Lockheed Martin decides to call its heavy lift vehicle. The short form answer to your question is substantial. There is substantial government assistance to those programs.
I think there's another aspect of this, if I may.
Yeah.
I think there's another aspect of this, if I may, and that is there are different classes of economic accounting. And I'm pretty sure, for example, in France, that if there is a town that's heavily dependent on the space business, they will subsidize to the extent that it's cheaper to do the space business at a loss than to put all these people on unemployment compensation. And I think that there are a number, it's not a black and white question. There are a lot of subtleties associated
and of course,
with it.
we don't keep space installations working in the United States because of their employment impacts, right?
There are some
the cultures are so different, and the relationship between the government and the private sector, so you could go on forever. Sir?
Yeah, there's been a lot of talk recently about these companies trying to get started with space tourism and stuff.
Yep.
Are these people, in your opinion, are these for real? And are we going to see something in the next, 10 years or something like that?
Whew. I don't give investment advice because I don't invest. Almost all people that have succeeded in new businesses were thought to be fools at some point. Many people who propose new businesses are fools. So the trick is finding out which ones aren't. Is there anyone out there that is going to make millions or billions of dollars in an innovative new space-based business in the next 10 years? I'm skeptical. Next 25? Sure. 10's pretty short for this business. But 25 is not short.
I'd like to comment of the question, are they for real? I'm on the scientific board of one of these companies. They're for real. These are
What do you
real,
mean by real, by the way?
These are people investing money who come largely out of the travel business, and not out of the space business, and they are convinced that the field of adventure travel is such that there's an ample market for people who will take short trips in space from suborbital up to 3 orbits and pay for it less than people pay to get carried up Mount Everest, which is to say of the order of $50,000.
Well, the one company who's taking reservations is charging $98K.
Yeah, but they really estimate them in orders of magnitude as between 10,000 and 100,000. But there are 3 companies now who are in the business, one taking reservations, and I think it's real. I believe we'll see them and sooner than you might think, within less than a decade.
You suggest that it's complex. It's got a real part and an imaginary part.
Yeah.
Thank you, Professor.
People who you wouldn't associate with, well, this is MIT. Geeks are all right up here, right? Or some of the time. It may be people who are not socially acceptable or smooth salesmen, but have creative ideas and the willpower to see them through that will do this. So depends on your definition of real. Sir.
I'd like to move to the space science stuff that you addressed. Obviously, Dan Goldin's had a huge effect on getting the space science program moving a little
And
more
Wes
quickly.
Huntress, by the way.
And Wes. But I get the impression that he still suffers from the other old NASA disease, which is once it's off the pad, we don't care about it anymore. That the amount of resources into follow-up data analysis and so on compared to let's get another mission going there's still some issues there. What would you comment on that? And I'd also like, as a follow-up, to say, what do you think the impact has been of the Discovery and New Millennium programs in terms of, there's been some criticism of Pathfinder not really delivering a lot of science. Maybe that's okay.
Those are all better questions than I have answers. I'm not really if you asked me what the data analysis budget was within the NASA Space Science, I couldn't give you a reasonable answer. I am told, I think, that OMB put a reasonable amount in the fiscal '99 budget request, recognizing precisely the syndrome you're talking about, that there is a recognition that doing something with the data, plus putting it on internet and slowing down the proprietary control by the principal investigators, or not slowing down, loosening it up. All of that is, I think, going on. One of the graduates, how many of you were undergraduates? we run a program in science, technology, and space policy at my university, which likes to have graduate students. Ask Ms. Weigel back there. She can tell you about the experience. Anyway, one of our recent graduates is now the OMB budget examiner for the space science program, and he carries an astrophysics degree from Harvard into that, so he knows what he's doing anyway. I don't know whether he's gotten the bean counter mentality totally. In fact, I know he hasn't.
I think it's more NASA than OMB here, in that, you know, we get told, oh, we're going to switch you off after a year.
Yeah. No, I understand that. Well, but it's related exactly to your second question. Nobody pays attention to data analysis. And when you launch a technology demonstration mission, it gets criticized because it doesn't do much science. I mean, the whole expectation is all of this is somehow only about science. You know, the scientists have taken the lead in creating that expectation that if it ain't science, it ain't worth doing. How much science is John Glenn going to do, for example? You know, it's not a neat, rational, close-in world. There is an overhead cost to the public support of space science at, depending on how you want to count, $4 or $5 billion a year, combined Earth and space science. That's a lot of money. And to pay a little price for public support and understanding is not bad.
I have a question for the driving forces for human settlement outside of Earth. You mentioned two criteria, one being, you know, can we use extraterrestrial resources? And second, is there economic value that can be created by it? My question is related to a third one that I think might or might not be a driver in the future. I looked at a chart of the evolution of the world population recently, and it's really stunning what has happened in the last 150 years. You know, how stable the world's population was throughout the Antique and the Middle Ages, and how it's just exponentially been shooting up in the last decades. Do you think that that could be a potential driver for, I mean, I'm not talking 20 or 30 years, I'm talking longer into the future. Could that be a driver?
Could it be? Sure. How likely is it? I mean, drive around this country and say, would it be easier to terraform the western desert or Mars, for example? I mean, you make more habitable land on this planet compared to creating the environment for space for human settlement on other planets. I don't think that's going to be a driver. Maybe species survival will be, and human curiosity and just an impulse. This McCurdy quote I had at the start, his book is about the character of this vision and the drivers of this vision of human exploration and settlement. And he argues that it's rather peculiarly American and in some degree or at least Northern European American, and in some ways a product mainly of the post-war period, not something, he kind of tries to debunk the whole frontier myth in American history and the notion that space is the next American frontier. And you can argue, I think he overstates his argument, but
Let me just ask if what your assessment is of the probability of a human Mars mission being decided upon within 25 years.
Decided upon?
That is a positive decision to develop.
I understand the question.
Not launched, but decided upon.
I engaged in an interesting discussion Monday with people in the executive office of the president who are beginning to think if a president wants to do either this one or the next one, wants to make a major space decision, is there any alternative to humans for Mars? Or is that the only thing on the decision plate? They don't want it to be. They don't like the idea of a single option being presented to any decision maker. There is this strength of conviction among a lot of people in our business that it's Mars or nothing. Time frame. 25 years, I'm willing to bet, since I won't be here to collect, well, I might be, I hope, that the initial decision to start an international expedition to Mars will have been taken. Yeah.
I have a question. Actually, I have a comment on the space tourism, whether that's real or not. It's definitely true that they're booking, the Stanford Tourist Agency, it's booking for $90,000. If you look a little bit behind, the center here is intimate with the company that's promising to do that. If you look at that, there's 4 marketers, 2 lawyers, and 2 engineers, and they're going to do it for $500,000, which is my related question. With the large growth in space that you see, I mean, the curves are just going off the chart. How's the government going to deal with, this doesn't really seem feasible, and I'm actually thinking about in terms of bandwidth, because you have to get licenses, you have to go through this agency currently, and if everyone and their brother is starting to ask for, we need this bandwidth, we need this frequency, what's going to happen? What are we going to do short term to fix that problem?
The question you asked didn't quite match where I thought you were going, so let me answer both where I thought you were going and the question you asked.
Even better.
I thought you were going to talk about licensing of human travel private travel to and from orbit, which is not a bandwidth issue as much as it is human safety and reentry and all that sort of thing. The Commercial Space Act, which is out of committee in both the House and Senate, hasn't been passed by the Senate yet, has the initial provisions to begin to license reentry systems, which we have to do before X-33, or at least anything that would follow it, or Kistler for that matter. That's one of the reasons that Kistler Aerospace is the Seattle-based startup that claims to be starting its flights later this year, but they're starting their flights out of Australia, Woomera. Because there's no licensing authority in the United States for it yet. So there's a general comment which relates to all part of your questions, which is the role of the government as these private sector uses of space expand will have to include regulatory as well as R&D support, creating regulatory regimes, rules for these new sectors of activity. And in particular, the international body that allocates frequencies, which is the International Telecommunications Union, is widely viewed as broken and not the way it does business, not the right way to make intelligent decisions on this extremely scarce and extremely valuable resource. So I think that's an issue that leaders around the world concerned with this are beginning to address. The next World Radio Conference is 99, and it's supposed to be the frequencies for long-term GPS, for example.
How would that body differentiate the good stuff from the bad stuff? The real stuff, 3 engineers, or do you have to come from a respectable company? I mean, what's the criteria?
I don't know it well enough to give you a full answer, and the full answer would take a long time. Basically, though, it's a bunch of delegations of countries that come together and vote as one country. So there is some thought that the less than reputable places become hire on the representative of Ghana or what country I can insult that way, to carry their interests rather than fight within the United States to get their interests advanced. The international politics of that is an interesting question.
Did you have a question, Don?
Yes. Yes, I had a question on the learning from space station, and I'm wondering how much has been learned from Mir and how much that's modified the way we plan doing space station.
You're asking me, or you're asking Larry?
I'm asking in general.
Okay. I can tell you what I've been told about that by some people who I trust, which is that the main thing we've learned from Mir is the way to do work in space. long duration work, the kind of preparations, the value of redundancy, the ability to have flexibility in your work schedules, the type of crew training and procedures, rather than any of the science qua science. And you might want to add to that.
I'm afraid that I've had relatively similar feedback, which is not very much new hard science with respect to humans living in space. Not tremendous surprises and not much data, but an enormous amount of experience related to how to solve problems in long-duration weightlessness, and something that Chuck Ullman has brought to our attention, that there's a big difference between 2 weeks and 2 months in space. And there becomes a period in which the psychological reactions to living up there for a long while become dominant.
Yeah, that was my flipped comment about shuttle just being a camping trip. You can get along with people if you know it's a short time. But if you're there for a long time, you either get along or you have the experience that the Biosphere 2 had of split into warring camps, which would not be good on the way to Mars.
Now, we have people in the Center for Space Research who have had mere experience. Any comments for them? No. Perhaps one last question. We will let Dr. Logsdon go. You've had one. Dr. Stocklosa. Yeah.
Yes, John. Talking about station again, I think you had a comment when you were talking about humans in space, and you said we have to do station before we do anything else.
Yep.
Did you mean that from a political standpoint or from a mission operations standpoint?
Political. I think the plan that's been laid out for how one does space 50 years ago already got short-circuited by Apollo, by a political decision to go to the moon. But the notion that there are more compelling scientific or other reasons to go send people far away from the Earth without first finding out what they can do near the Earth, just it goes against common sense. So there is a technical justification to it that before we go venturing out across the seas, we ought to find out what humans living, working in a well-equipped laboratory in the space environment can actually do. Hopefully we will.
Let me ask the students who are members of the course in Modern Space Sciences and Engineering to join us in the back, have some cookies, and then we'll have an informal discussion with Dr. Logsdon. You can also hand in your assignments that are due today.
Yeah, I didn't know I was party to that.
All the rest of you, thank you for joining us, and John, thank you for an outstanding lecture.
Thank you.